Hello everyone. In the previous module, we discussed the third A part of a third unit, that is a magnetic field. In this part, we will start the second part of a third unit, that is the forces on a charged particle in electric and magnetic field. In this part, we will discuss that how the charged particle who is carrying a charge will behave like in a electric or in a magnetic field. So we are going to start with the first topic, that is a motion of a charged particle in uniform electric field. Firstly, we will consider a particle who is having a mass m and carrying a charge q, which is moving with the velocity v towards the x-axis. It is moving in a direction of a y. Now we have to check that what path will be followed by the particle who is carrying a charge q. Force on a charged particle, that is F is equal to QE. We already know the formula. F is equal to QE. A is equal to F upon M. We will put the value of F, that is a QE upon M. If X is a length of electric field, then time taken, that is a time taken, T is equal to distance upon speed. We read the formula, speed is equal to distance to the time taken. Simultaneously, we are finding the formula, T is equal to distance upon speed. Distance is a X because it is moving in a X direction towards the Y direction, but in a X direction. X upon V because it is having a velocity V. Y is the displacement of a charged particle along the Y axis. Then we can write the formula, Y is equal to UYT plus 1 by 2 AY T square because it is moving in a direction of a Y. Y is equal to, in a y direction, its initial velocity is 0 because it is moving in a x direction. 0 into t plus 1 by 2, we will put the value of a QE upon m, x upon v whole square. Put the value by following, we will get, that is a QE x square upon 2mv square. If we will see the relation, we can find it as x square is equal to ky. If we will see the relation, we can find this is the equation of a parabola. This is the equation of a parabola. Hence, inside the electric field, the charged particle moves on a parabola path like OB. We can see that is a OB. It is following a parabolic path. This clearly shows that if a charged particle who is having a mass m carrying a charge q, if it is in a moving of a electric field, it will take a path of a parabola. Now in the next topic, we will discuss if the charged particle is moving in a magnetic field, which path will be followed. We will consider this is a magnetic field. This is a magnetic field. It is moving with the velocity v. If it is making angle theta, it will be distributed into two components. Again the same charge, we are considering a mass m, charge is a q, and magnetic field, that is a b, and the velocity will be distributed into two component, v1 that is a v cos theta acting in a direction of magnetic field, v2 that is a v sin theta acting perpendicular to the direction of a magnetic field. The component velocity v2, the forces will be magnetic field. F is equal to q into v2 cross b. Force is equal to, this is a Lorentz force. F is equal to q v cross b. If q v cross b, that is a cross vector, that is a sin theta. v2 b sin theta. Angle between velocity and the magnetic field, that is a 90 degree. Sin 90 is equal to 1. We will get F is equal to q v2 into b. v2 that represents for the sin theta factor. The direction of this force is given by the Fleming left hand rule or right hand thumb rule. We already discussed in the 10th classes. These are the two rules to find the direction of a force. Right hand thumb rule and the Fleming left hand rule. Then the magnitude of velocity v2 but only the direction of motion of a particle. So we will find that what will be the direction. We will see that the direction of this particle will be a circular path. According to the right hand thumb rule, this will give the direction of a circular path. The direction will be circular. The centripetal force required for this is q v2b is equal to, this is a force and this is a centripetal force because it is a circular path. So the centripetal force will be equal to the force which is by the Lorentz force. q v2b is equal to mv square upon r. v2 is equal to qbr upon m, and the radius by this is, that is r is equal to mv2 upon qb. The angular velocity we can find it as omega is equal to V upon R, V is equal to R omega. From this formula we find that omega is equal to V2 upon R. Omega is equal to QB upon M. Frequency, omega is equal to 2 pi nu. Put the value, we will get that the frequency. The time period of this is, that is T is equal to 1 by nu. Nu T is equal to 1. T is equal to 1 by nu. T is equal to 2 pi m upon QB. For component velocity, V1 is equal to V cos theta. There will be no force on the charged particle in the magnetic field. Then V and B is 0. The charged particle covers the distance in the direction of magnetic field, V cos theta. So the direction, sometime it can be direction the linear path as well as the circular path, that is a helical path. So if the charged particle is moving inside a magnetic field, it will be followed by the circular path or the helical path. The distance D is equal to V into T, V is equal to V cos theta, and the time is 2 pi m upon QB. So we discussed about that. If the charged particle is moving inside an electric field, the path will be followed, that is a parabolic path. If it is moving inside a magnetic field, then the path will be circular path, helical path. From this we will find the Lorentz force. The Lorentz force, it will be the addition of a electric field in the magnetic field. F is equal to Fe plus Fb. F is equal to QE. We already find by the electric field. And simultaneously for the magnetic field, Q V cross B. If we will consider the case 1, Q, E, B all are the collinear, means magnetic force will be 0, means the force will be due to the only electric field. There will be a change in the speed of a particle along the direction of a electric field. Second case we will consider V is equal to E, B. Mutually perpendicular. It means Fe plus Fb is equal to 0, means A is equal to 0. The charged particle will pass through the field without any change in its velocity. Means QE is equal to QVB is equal to V is equal to E upon B. This is the final relation. And we have to learn these equations also, because we will use these equations also. The radius which will be followed, omega, that is the angular velocity, that is a frequency, the time period. And the same relation we will use for the cyclotron. In the next module we will discuss about the cyclotron. I hope you understand the topic. Thank you so much.